Kubernetes Security Learning Series point of view. 17th topic is minimize base image footprint. So I'm in a training.linuxfoundation.org CKS syllabus, and if I scroll down under supply chain security, minimize base image footprint. Let's try to understand minimize base. So cloud native security, 4Cs. So we are talking with respect to Kubernetes. Say I'll go to the Google and say type Kubernetes cloud native security. The first link is this. I clicked on here. So 4Cs of cloud native security. Let's try to understand that. So with respect to the 4Cs, all the infrastructure, we are talking about the Kubernetes infrastructure is hosted in any of the cloud, maybe cloud or corporate data center or anywhere, right? Co-location or anywhere. That's a first center level security. Second is a cluster level. Cluster means one master node and multiple worker nodes, that level security. And the third is a container level. So Kubernetes cluster means pods. Pods are nothing but inside the pod one or more container. Each container will have some code is running, right? Whatever the language. So as a part of a defense in a depth and security point of view, we need to protect the container level. So this whole topic basically under the CKS syllabus, supply chain security, whole topic is talking about the containers. So let's try to go inside. Minimize the base image footprint as a title. Basically base image means what? A Docker image. How you prepare a Docker image? By using a Dockerfile. So how the Dockerfile will looks like? This is the way a Dockerfile looks like, right? This is a node specific Dockerfile, right? So basically if you look at here, Docker hub node, I'll just type here and I'll get a node official image, right? So if you look at here from node 14.19, right? So basically these are the Docker image, and if I go to the scroll down, there are so many tags are here, there's so many versions are here. So if you analyze this Docker file, the first image is used as a from node 14.19. This is the base image. Then working directory copy, something is running and exposing a some port and some command is running with this image. So this is a simple to understand a Docker image. And here the same thing, I go to the tags and node 14.19, right? Say here, here I search for 14.19.0, right? That's what is there, 14.19.0. If I search for a 14.19.0, there are a lot of results. 14.19.0 Buster Slim, Buster Bulleye, right? And Alpine, and Alpine there are various versions, 3.15, 3.14, right? So so there are many versions, and if I look at this, there are many results. So this is a normal 14.4.0, and then the slim version, stretch version. So these are the various versions it's listed, right? So which one to use? Basically first of all we will try to understand what is the base image here. So whenever you take any container, is a what is the image? Image is nothing but a template for a container. So what is this template? Contains operating system and its runtime and the dependencies and libraries. So let's try to understand. So basically if you look at the Docker image, right? So basic fundamental is Docker image point of view, every image has a base image. So if you go to the Docker hub, right? Docker images samples, just I search, right? So docs.docker.com is a very official website of a Docker, right? So I'll just take any example. So Docker for Java, Docker for Node, Docker for ASP.NET. I just opened 3 different tabs here, right? So these are the official links are opened by the Docker. So if I look at the scroll down, right? Not this, right? If I look at here, .NET Core application, say yeah, .NET Core, this one is enough. If you look at the .NET Core application, if you look at here from some image as a base, then working directory copy run and all is happening. And then see here, every Docker file you take, there is a base image. So in order to build your any of the hello world Docker image, you need to have a base image. That's what this is the base image. right? And then the second is basically we will be updating the packages. So you will take a one fresh image, and on top of that you will add some packages, and on top of that you will add some build tools, right? I wanted to build a hello world application, and on top of that I will add some build time libraries or package dependencies, right? If I want to do this, build some dependencies, and on top of that I will add some runtime specific system libraries, etc. Then once everything is done, what I will do is, then next is my application layer will come, then my application will run. So, and this is all, everything is a Docker image. Whenever I create a container, what happens? My container is a read write, but whereas a Docker image is a read only. Just remember. And this entire the base image package, these all are as a read only, and it will be added as a layers one after another layer, and each layer has its own cryptographic hash, and it will cache as well. So that we'll see the further, but the point is here, Docker image point of view, these layers are read only, and application container layer is a on top of that the Docker point of view, and that is a read write. So whatever you do, deploy or anything you do, only here, not on this here. These are the basic core for the Docker. The next, sample images. So basically if I wanted to see the Docker images, right? So here is a Python, right? If I go to the Docker, I'll close this, right? So hub.docker.com, and then here Python, I'll just search. I can open and search it as well, but this is simple, right? It's opened me the Python. So this is a Python. So if you look at this example, right, I am pulling a Docker pull Python 3.9.0. So I am in a Python, and then go to the tags 3.9.10, right? 3.9.10, right? So if you look at the 3.9.10, same like a Node.js, right? So there are various versions are written with Slim Buster, Slim Bully, Slim and Buster, Bully. So 3.9.10 Alpine. So there are various versions, and 3.9.10 Alpine. So here these are the images. Each image has its own size. So how to prove that? I have a Docker is installed in my Mac. If I say Docker images, right, I already pulled. If you look at this Python 3.9.0, which is 885, right? 3.9.1, this is a normal one, right? Which is this guy, 3.9.10, which is a simple, this one. This is a size. Anyway, of course, it's a size is mentioned here. If you look at here, right, which version you use, accordingly its size will show, right? And how about the Python Slim version? Buster is a 855, which is same as a actual one, but it has some additional added benefits. Slim version has a 128. Wow, it's a same Python 3.9.2 Slim is a 122. If you look at the Alpine, it's even more smaller. So this is a 48 MB, which is a very, very, very smaller, right? So in the Docker images point of view, every image has various sizes based on the it's basically its names. It's called a Docker image names. So we'll see. So our main topic is today is a Kubernetes security point of view. Minimize a base image footprint. So basically whenever you are building an Docker image, whatever the base image you are using, that has to be minimized. Otherwise your each and every, if base image is 885, your entire application it will be in the GBs, because it's close to 1 GB, right? So how to do that? Basically the first point is always use a slim or minimal images than a base image. Yes, of course, base image is 885 MB, slimmer image is a 122. That's what it's a best practice is seeing with respect to Kubernetes security. Then second is a Alpine. Alpine is what is Alpine? This is a very, very slow. Alpine is a security oriented lightweight Linux distribution. Alpine is one of the version of a Docker image where it is a Linux distribution, and it's a security oriented, which doesn't have a much utilities. And what is another way to reduce the base image footprint is use a multi-stage builds to optimize the image. If you do the multi-stage build, then you will be able to achieve the minimizing the base image. That's what minimizing is. Not only the reducing the size, but also you will be reducing the its exposability, reducing the its reducing the security, right? Reducing the security breach, I mean, right? So, and there is another Google's Distroless images, that also we will see. These are the, what is this Distroless images? Apart from these three, Distroless images are basically, whereas it has only application and runtime, that's it. There are no package manager, shell, network tool, text editor, etc. Then other one is, what is the benefit of a Distroless images? We are the very very small and better for production, so that in the production images nobody will be able to run any network or shell or any type of command, so that your image is secure. Yeah. And what is another best practice to, in order to reduce the base image footprint, is remove the unnecessary cult. So basically, if you remove the unnecessary craft, then your image will be less. How it will be possible? By using a Distroless, because Distroless has a very very less. And if you are using a slim or multi-stage or any other type of fable, then better to remove the unnecessary craft other than what your application is required. Then let's go to the, so we have seen this here, right? In the Docker we have seen that there are many versions, right? Buster and Bullseye, right? Alpine, and there are a Stretch, right? Slim and all. So what is the difference between these? Are the, just try to understand high level. First is one is a full version, right? Full version is nothing but this guy, Python 3.9.0 885. Basically full version has a lot of tools inbuilt and software, and it's a source control specific, runtime libraries, and also other many more dozens of libraries to utilities and all. It's a heavy weighted basically a base image where it has everything inside, lot many things you can do. This is a full version. But if you wanted to run a web server or anything, do you need this full version? Not required. You need a slimmer image, because this is a slim. What exactly this slimmer image? Slimmer image is basically pared down version of the full image. Basically it's inherited from the main image, but it will not have as many as utilities as the full version, so that it doesn't require it. If you are using a web server, you don't need the utilities and all, right? You just need a web server. That's what the, and other one is Alpine, which is a very very small 48 MB here. What is a Alpine? It's a Linux is a distribution, and each and every version is intended for the its own purpose. Here Alpine is basically built for a smallest images, and it's a very very minor, and which is a 1/5 of the 1/5 of the slim. Yes, almost it's a, yeah, it's a kind of 1/3 here, but differ from the image to image. I am taking the Python as example, but if you take another example, it will be very less. That's what. And there is a final one, the Distroless. So if you go to the Google, right, Distroless images, right? So if I go to Distroless, right, it will take me to the Google. So this Distroless is invented by the Google, and Google has this Distroless. So whatever the image you are talking, this is available in the Docker, but the same thing is available in by Distroless Google as well, so that it doesn't have anything inside, just application and runtime, which is more secure and very very small as well, small like a Alpine, right? Now next is various image names. As we seen Alpine and all, right? Alpine is nothing but it's a package manager, has a APK, Linux APK, and it has a shell, only one shell. That's why it's a very small. If you look at this Alpine, right, this Alpine, it's a 48 MB, which is nothing but only one shell it has. You can create a container of this particular image and you can go inside, then it will have only one shell, and it's a very less MB, start from 2.7 MB. If you look at the Node.js also, there is a Alpine image. So if you go to the Node.js, right, there is Alpine 4.19.10, right? Here Alpine, see Alpine, which is a very less 40 MB, right? So basically, otherwise if you look at this Buster, right, it's a 334 MB, right? So likewise, and this is a so likewise. Now the next is basically Jesse. This is also one of the image name where you will be able to find in the Docker, right? And that has a lot many shells: bin bash, csh, dsh, fish, ksh, mksh, zsh, there are many more, and its size is a bit higher. Then third one is a stretch, which is basically it's a Debian 9 based version. That's why there is a difference. If somebody using a Debian 9 or Debian 8, Debian 8 means Jesse. If it is a Debian 9 Linux, then go for a stretch. So it depend on the your application and how your application is requires what kind of a base, right? And other one is a Buster is a Debian 10. So if you look at this version is a incremental, right? Here 8, 9 and Buster is a 10, which is nothing but Buster also has a lot many. That's why Buster's size is a higher, right? So yeah. And then Ubuntu is a one of the another image. Basically you can just go and search for Ubuntu as well. That is very less, but it's based on the Debian for the generic. So in this way you can see the many more, and you can go to the wiki and search for it. I will go to the Google and just search for Buster Debian wiki, right? If I search here and the Wikipedia Debian, so if I go here, right, there will be a version history as well here. Not this, there will be a Debian version history, right? Yeah, so if you look at here, right, so there will be each and every release history has a wiki. Say Buster here, if I go and click here, and it has a lot of information about the Buster here. So every version and its related information here. So the basically the base reference is a wiki is the best if you wanted to try to understand about the stacks. Now next move on to the tips for the Docker image sizes. So how to make Docker images lesser. First one is use a smaller base image or Distroless image. Basically if I have one application called Hello World, let me open that. CD projects Hello World. I have Hello World JS, which is an application I have. So I will try to open that Hello World JS, right? 1 second. Now the most important is tips for Docker image sizes. If you wanted to make it the lesser Docker image sizes, so then these are the tips. First one is use a smaller base image as a Distroless image. So as I show in the previous example, right, you have to use a smaller base image. Second is do not install a debug trace network tools like a curl. So let's try to understand one by one. First one, I have a Node.js application, right, ls, right? So I will open in a Visual Studio Code so that we will see clearly, right? So my Visual Studio Code is open right here. So there is a Node.js application which is a very simple one. So what I will do is I will try to Dockerize this application by using all these rules. First one is basically, in order to Dockerize, first of all you need to create a Dockerfile, which is a capital D Dockerfile, right? So how you create a Dockerfile? By using a simple, right, from this a Node.js application, right, from what is a version node : and what is a version here, we search 14.19.0, right here 14.19.0. so first we will try to do the regular version 14.19.0, right? So 14.19.0, this is a base image, right? So what is the first principle is use a smaller image or Distroless image. So I don't want to use, I will use a normal one, and let's see. And then how to create this Docker image, I know, so nothing to worry about this, how to create and all, just for the sample, for a demo point of view. So my working directory I am setting as an app, and as well as I wanted to copy what is a file here, server.js, right? So server.js to into the container. So I'll take a container, set as a working directory and copying here. Then after that what I will do is run npm install, because this is a Node.js application, so I need to install a Node.js into the this one. npm install means all the required packages. Now after that, what is one expose, and I wanted to expose on a 3001 port, right? Then now I think 3000 is enough. Now next is anything cmd npm start, right? So I have a GitHub autopilot copilot, so automatically it's suggesting. So this is a standard image which I created. Now in order to run this, basically this, since it's a Node.js application, then I have to do the npm init. So I'm in a same directory here, right? So I'll do the clear ls Dockerfile and server.js. Now what I will do is npm init. Basically it will initialize the project.json. So basically here project.json is required. What is the package name? Hello world. Yes, okay, let it be. Version let it be and all, and okay, and we are not bothered about this, right? Perfect. Now clear. Now package.json is created automatically. Here, go here, package.json, which is a Node.js specific. Now first what I will do is I will try to build the Docker image. So how to build the Docker image is a very simple. Docker build, right, -t. What is the Docker image name I wanted to create? Hello world and general, right? Hello world general, that is a Docker. Then after that put a dot, that's it. And hello world general, I wanted to just give it as a 1 version. It's okay, you can create anything, just hello world version 1. Then after that dot. Then what happens is when I do that, then it will start building the Docker image based on the this configuration right here, right? So working directory is created and copying the server.js and npm install, and right, and then it's trying to create that. Oh, it's created already Docker images. If I see this hello world general, how much is the size it took? 946 MB, right? So, and here one thing is I forgot, I have to copy the package.json also. So what I will do is package.json to the container directory. So what I will do is I will docker rmi. I wanted to delete this image and I will recreate, right? Now clear screen, docker images, right? Now I'll rerun the same command again, right? So now, right, now it will recreate the image, right? So it's created, it's getting created. Yeah, perfect, it's almost there. Now docker images, then I can see 946. This is a general image. So what is the thumb rule saying? Use the smaller image, smaller base image as a Distroless image. That's so if you look at the if you wanted to use as a smaller image is what? Alpine, right? So if you wanted to use Alpine, say -Alpine, what I will do is here I will do the Alpine, right? Then no, what I will do is I'll just try to copy this and create another Dockerfile dot Alpine. So al I will create, just I'll put it here, and hyphen, what is the image name here? Alpine here, -Alpine, right? -Alpine, right? Here this one. So -alpine, right? Now copy. What I will do is I have to create another Docker image by using this file, so not this one. So what to specify? Docker build -f, then you have to give the file name dockerfile.al, right? After that -t, then after that what is the image name? Hello world -alpine. I'll give this name and dot. So now if I enter here, then it will start building the Docker file by using this file, which is I'm using a Alpine. So it's trying to create, right? Step number 1, it's building. So let's wait for the I will pause the video until the image creation. Yep, it's now completed all the 4 stages. So now what I will do is I will clear and Docker images. If you look at here, hello world general is a 946, whereas hello world Alpine is a 119. So there is a lot of difference after changing the only base image. Rest of the things are same. So that's what this particular point is. Use a smaller image, base image. If you wanted to use a Distroless image, yes, you can use a Distroless image. How to find out the Distroless? GCR node Distroless image. Just you search, right, Distroless Docker images, and you will be able to find out the its repository URL. And see, this is the one, Distroless images node.js. This is the Docker image. So right, this is the what the URL you have to give. So this is the Distroless 14 version. Right. Then we'll go to the next one. Do not install a debug trace network tools like a Vim, curl, nano, trace, etc. Basically, whenever we are building a Docker file, here sometimes we tend to install run apt install -y some Apache utilities, right? Something like that we tend to install, right? So Apache to utilities. So this kind of a utilities, whenever you need, then only you install. That's what this particular point is saying. If you try to install a Vim, curl, nano, trace, these are the network tracing debugging tools. If it is for development environment, it's okay, but if it is for production environment, it is not required. That's what the best practice is saying. Third one is minimize the layers. So you say, for example, there is a Docker file, right? I'll show you one example, right? Say this is a run, right? Say I wanted to run really run apt update -y and run apt get, -get, right? Here apt -get, right? So install y. Then after that, say apt get install -y. I want to install a Vim or network tools, right? Say run apt get install, say net tools, right? So net tools, right? Net tools. So you are like in the Docker image, you are trying to increase the layers basically, right? So whenever I build the Docker image here, right? So here the layer 1, layer 2, layer 3, layer 4. So in the form of a layers it's building. So instead of that, what you can do is the best practice is suggesting is you can specify in a one-liner in this way. That's what it's saying, right? So in this way you can reduce the number of layers and you can keep it in a one single line. In this way you can reduce the number of layers to one layer. That's another practice is saying. And use the multi-stage build for the final optimized image. So I have a multi-stage build, multi-stage example. So what exactly is, I will try to create a Dockerfile.ms, which is a multi-stage. So what I will do is I will take actual Docker and copy here, right? How can I make a multi-stage? Basically here we are making as a 3 different stages, right? One is a base stage. Base stage what I will call as a build stage, right? Then I have taken the first one, then everything is done. Then here what I will do is, here I will take the another base image, which is a very lighter one, and what I will do is copy ---- from where equal to build. This build is nothing but this guy, right? From build, which directory you are pasted the applications, app, to where in this slash, here also kind of app, here also app, in this way, and expose 300. So basically if you look at here a multi-stage build, you go to the Google, right? Go to Docker multi-stage build and you will see the official Docker documentation. And here if you go here, multi-stage build, use multi-stage build. Basically what we are doing, instead of building a one single Docker image, you will be doing in a multiple stages. Here the stage 1 and stage 2, right? This is the what the example is given for the Golang, right? So what you will be doing in the stage one, you will be taking a heavy image, which is the actual image, and you are copying the working directory and all these things, right? Then after that, you are taking a very, very lighter image, then copying the whatever the build content into the here. So that way you can reduce the multi-stage, right? Here this is the my multi-stage image, this is the my stage 1, this is the my stage 2. In this way I can reduce the image, right? Say if I go here, right, I can give the same command and it will build, right? Let me show that. Docker build, same command, but the thing is instead of al I given the name as a ms, right, which is a multi-stage. So ms, right, and instead of Alpine I'll just do the ms and then enter, right? So basically it will create a Docker image as a multiple stages. So in this way also you will be able to create a Docker image. That's one. And other one is a no install recommendation to get a apt get install -y can help to reduce the size. Yeah, so basically whenever you are see, this is already created, so let's Docker images, right? If you look at here, multi-stage build also 119. Why? Because my application is a very small, that's why there is no difference it's making to the Alpine and ms. But if you really use the application with a huge different content, then definitely there varies between a multi-stage and a normal one, right? And no install recommendation. Basically what happens is whenever you are using a Docker file, this kind of a Docker file, right, after this particular utilities installation, basically this will be reused by the system. So, and it will automatically suggest an recommendation installation, because you are passing a -y. -y means it won't prompt you for asking to whether yes or no. So this will basically, it may install unnecessary. Say I installed here a Vim, but it will install a lot of net tools here, right? So this is the one of the technique to reduce. I will show that. And second is a copy only required content. Some people what they will do is, instead of this one, right, say here, say important file, I have some important file, let's consider. Then say in my Docker file, if I specify copy ... then what happens is, here only server.js and package.js, and these both are getting copied to the container. But if I do the ... what happens is everything will be copied. If my source code is 100 files, all 100 files will be copied. So that's against. So copy whatever the folder, that's the best practice. And other one is a add rmrf var lib apt list to the same layer as a apt get install. So what happens is whenever you install this kind of utilities, these all will be stored in this container in one of the location, which is this location. So whenever you build a Docker image, you have to remove. That's the best practice. And the last is use a Docker caching layer. So basically this Docker will do the caching. So you take a base image and you run the update as a second step, then you do the your stuff, because whenever I rerun this al, then automatically it will reuse this as a cached layer. And the last but not the least, it's there is a from latest.io which is to fine tune a Docker image. Say for example here, what is the website? From latest.io. From latest.io, I'll open here. See, this is basically whenever you post any Docker image, it will suggest you what are the problems. This is the best to investigate. What it's saying, no installation recommendation, right? So right here what I have to do is, here in order to avoid this message, this is error here in this, right? What I will do is I will just put it here as a no install recommendation. It's gone here, right? Now Ubuntu latest tag I am using. So it's saying that latest tag should not be used. Always you should be using a only relevant image. If I go and search for Ubuntu image, right, this is official Ubuntu image. and I'll go to the tags, right? And what is the tag is here, say jammy, jammy, right? So let's take anything, jammy, right? Now that error is gone. Now capitalize the Dockerfile instructions. This copy command is a small, so as per the Docker rules it should be in a capital letter, right? So in this way there are no problems with my Dockerfile. So this way you can leverage the from latest.io any Dockerfile, any Dockerfile, so that you can validate, right? So right, then after that the last one is basically use a dive or Docker Slim open source for Docker image optimization. So basically there are free open source tools. Basically these are the image optimization, dive and Docker Slim. Say I'll go to the Google dive GitHub, right? This is a dive, right? I'll open in a new tab, and other one is what, Docker-Slim. Say here Docker Slim, just simply enter, right? Docker Slim, right? Say I'll open this. So this dive is basically is one of the open source utility where you can see and what are the how many layers, how big is the size, you can inspect and you can validate and all these things, right? So by looking at this code you won't be able to identify where is a heavy concept is going on. So basically you can use that. And other one is the Docker Slim, which is basically one of the utility, is a very easy. You can minify the Docker image. Say you created a one hello world image, so here if you click here it will take you to the Docker Hub, right here. So whatever the Docker file, by using this Docker Slim utility you can make it smaller. In that way you can just make use of these tools to do. So these are the recommendation. That's it for this particular session point of view. For these all points are leading to the Kubernetes security, as why you wanted to minimize the base image. So you need to follow the certain security recommendations, best practices. Maybe you can go and search in a Google, and Docker has a very good documentation, and Kubernetes has a very good documentation, so you can just go and check. And thank you. I hope this session is helpful. If you like, please let me know your feedback in the comment, which would be really helpful for me. And thank you.